Today we're doing lesson 6.3, radicals and rational exponents. Our learning goal for today, I will simplify expressions with rational exponents. So, in order to do this, we need to think about what rational means. Just go back to 7th grade when we talked about rational numbers. That's anything that can be written as a fraction. So really what we're talking about here is we're getting into exponents that are fractions. And you'll notice this section is radicals and rational exponents, and that's because our fractions are related to the radicals. Another thing to remember, if I had like the square root of 4, this square root symbol, that's called a radical. So today we're getting into, when we go beyond just a square root, we actually call them nth roots. So this is the nth root of a. That's how you would say this. And this is saying, you know, like how this was the square root, what number squared gives you 4. This is saying what number to the nth power gives you a. So, you know, the third power would be what number cubed, the third root. The fourth root would be what number to the fourth power, that kind of thing. So, starting off with, we start with cube roots, which look like this. So this is the cube root of 64. And all this is saying is what number to the third power is 64. And it turns out that 64 is 4 times 4 times 4. Or 64 is 4 cubed. So the cube root of 64 is just 4. Just like with our square numbers, where it was nice to have a list, I would recommend having a list of cubes also. So, you know, 1 squared, 1 cubed, 2 squared, 2 cubed, just so you remember all of those numbers. The cube roots, you probably don't need to go much higher than, well, I don't know, 10 is probably about as high as I would worry about just knowing off the top of my head. So another example here would be the cube root of 1,000. It turns out that 1,000 is 10 cubed. So if I take the cube root of 10 cubed, I get 10. So the cube root of 1,000 is 10. We also have things like 7th roots. This is saying what number to the 7th power is 128. And I'll tell you right now, you're not going to see very many things raised to the 7th power, because normally that would get you a gigantic number. So if you see any big powers, try 2 right away. Because if you think about it, 2 times 2 is 4, times 2 is 8, that's 2 to the 3rd power, 2 to the 4th power is 16, 2 to the 5th power is 32, 2 to the 6th would be 64, I'm just doubling, so 2 to the 7th is 128. So the answer here would be 2. It just doesn't make any sense that something to the 7th power, or something any larger than 2 to the 7th power, would only be 128. So this is just the very first example, or the set of first examples, where we're just simplifying these radicals. So remember, this symbol right here is called a radical. If it's a square root, you don't need to have the number, but for any root beyond a square root, you do need to show it's the cube root, or it's the 7th root, or it's the 4th root, that kind of thing. So now that we've talked about nth roots a little bit, we can get into what a rational exponent is. So if I had something like the 4th root of 81, so what number to the 4th power is 81? Another way that I could write that would be 81 to the 1/4 power. So this 1/4 power means that I'm taking the 4th root. And it turns out that 3 to the 4th power is 81. So that means that the 4th root of 81, or 81 to the 1/4 power, is 3. To show that algebraically, so it applies to any situation, the nth root of a, another way of showing that is a to the 1 over n power. So whatever the denominator of your fraction is, that's what root you're taking. So another example would be, let's see, something like 16 to the 1/2 power. Another way of saying this would be the square root of 16, which is 4. Or 625 to the 1/4 power. Another way of saying that is the 4th root of 625. 5 to the 4th is 625, so this answer would be 5. So when you see that fraction, that's what it means. Okay, so for the above ones, you'll notice our numerator was always 1. So this was just taking the square root. This was taking the 4th root. But we can have a rational exponent that takes it a step further. Now it's to the 3/4 power, 16 to the 3/4 power. And if I were to break that fraction up, there are two ways I could write this. I could write the 3/4 power as 3 times 1/4, and that would give me 3/4. Or I could write it as 1/4 times 3. In both of those situations, when I multiplied them out, would give me 3/4. So I could think about this as 16 cubed to the 1/4 power, because remember, my power of a power tells me to multiply my fractions. So the way to solve this normally would be to multiply. Or I could write it as 16 to the 1/4 cubed. And again, I would multiply my exponents here and see that that's really just 16 to the 3/4. So instead of doing what we did in an earlier section where we simplified our exponents, here we're actually breaking this up into a whole number exponent and a rational exponent. And the reason I'm doing that is because now I can solve this. Over here, if I really wanted to, I could cube 16 and then take the 4th root, but that does not sound like very much fun. Instead, if I take the 4th root of 16, that's going to be 2, because 2 to the 4th power is 16. So this is just 2, and then it's being cubed. So 2 cubed is 8. So 16 to the 3/4 power is really just 8. So for another example, we could do 216 to the 2/3 power. And again, I'm going to split this into a rational, I'm going to make this a rational, I'm going to split up my rational exponent and make it a whole number and a fraction with a numerator of 1. So I'll do the 3rd root first. That takes care of the 3rd part. And then I square it, because 1/3 times 2 would give me 2/3. The cube root of 216 is 6, and I need to square that. So up here, I get 36 for my answer. One last one. If I have 25 to the 3/2, I'm going to take the square root of 25 first, or raise 25 to the 1/2 power, and then cube it. 25 to the 1/2 power is 5. That's the square root of 25. Cubed gives me 125, and that would be my answer there. So time for you to try just a couple on your own. Let's do number 1 will be 64 to the 2/3. Number 2, 9 to the 5/2. And number 3 will be 256 to the 3/4. So try these on your own. So for any of these rational exponent problems, I'm really following the same steps every time. First, I'm taking the root, and then I'm raising to the power. The other way around, I end up with gigantic numbers that I just don't want to deal with. So in this case, I'm going to start off by taking the cube root of 64, or raising to the 1/3 power, and then squaring that. 4 cubed is 64, so the cube root of 64 is 4 squared, gives me 16. Over here, I'm going to raise 9 to the 1/2 power first, and then raise that to the 5th power. The square root of 9 is 3, and 3 to the 5th power is 243. And then finally, for this guy, I'm going to take the 4th root of 256, and then I'm going to cube that. The 4th root of 256 is 4. 4 cubed is 64. So those would be the answers to the on your own. So now you should be ready to go with the homework with the raising to rational exponents.